Today we're going to look at the second half of Lesson 6, which is about how we graph conics. So again, we have our 4 types of conic sections that we've already talked about. In the last part of this lesson, we looked at how to write equations for conics that are no longer centered at 0. In this lesson, we're going to look at how to graph them. So the first thing you need to do when you're given an equation is determine what type of conic it is so that you know what it is that you're graphing. So the chart that is on your notes will be provided to you for the test. So what you want to do is look at the equation you're given and look at the chart and see what kind of a conic it matches up with. So what is this one? A circle. This looks like the circle equation. So then we need to find where the center of the circle is. The center is at the opposites of the numbers in the parentheses because the general form of the equation says x minus h and y minus k. So our h and k would be the opposites then of the numbers in the parentheses. So our center is at 3, -2. Then in a circle, what we care about is the center and the radius. What's the radius of the circle? 4. The square root of the number on the other side. So from my center, I'm going to go 4 in each direction and put a dot. And then connect them with as circular of a drawing as you can manage. Mine usually look like rounded diamonds. Questions?
Can they all be circles?
They will not all be circles, but the next one is a circle, so go ahead and try this one. This one is a circle again, so we need to place the center, which will be at the opposites of the numbers in the parentheses. So our center is over 1 and up 4. And then our radius is the square root of the number there. So we're going to go out 3 and connect with as circular of a shape as you can manage. Questions? What type of conic is this? All right, so I've heard all 4, so let's narrow it down. Okay. How can we tell?
Hyperbola because it's a minus, both of them are square.
Okay, so we've got the minus in there. That minus is the key that this is going to be a hyperbola. In a hyperbola, standard form has both of the variables as fractions, so we can put that first one over 1 to make everything into a fraction, so it matches standard form a little better. Now, when we place our center here, you need to be careful. On this problem, it doesn't actually make a difference, but in general, you need to make sure that your x is defining the x value of the vertex, and that your y value is defining the y value of the vertex. They're both ones here, but don't just take the first thing first and then the second thing. H is what's with the x, so x shifts for the x part of the center, and k is with the y, so that shifts for the y part of the center. So make sure that you pay attention that the x makes the x part of the center and the y makes the y part of the center, regardless of the order they come in the equation. So -1, -1 is our center. Then under the y is a 1. What do I do with that?
Is that you have to take the square root of that?
Take the square root of it, and it's still 1. And then how do I plot that?
You go up 1 to make the top of the box.
Go up and down 1. Since y is up and down, we go up and down the number that's under the y, square root of the number that's under the y.
Yeah, usually it's just the first one that's right. First one in the problem.
It doesn't matter what letter comes first. Just make sure that if it's the y, you're going up and down. If it's the x, you're going side to side. It does matter what letter comes first in the problem in terms of where our vertices are, so which direction it's facing. But as far as how we plot, Just make sure that y goes up and down, x goes side to side. So for the x, what do I want to do?
You want to take the square root of 4 and go up and down.
Okay, so we're going to take the square root of 4, which is 2, and we're going to go out 2 to the sides, and we make a rectangle for that for a hyperbola. So I go up to the height that was on the y, out 2 on the x, and make a rectangle there.
Why'd you go out to?
Square root of 4. So we take the square root of the number under the x, and that tells us how far to go sideways. Then we want to draw in our asymptotes, which are the diagonals of that rectangle. And since the y came first on this one, it's going to be in the up and down sections. If the x comes first, it would be in the side and side sections. Okay. Y first, that's up and down. If x came first, it would be the left and the right. Yes? Because of the minus. A hyperbola is the only one that subtracts. It could be an ellipse or it could be a circle if it's adding. And that depends on whether the numbers in the problem and the denominators are the same or different. The next one is also a hyperbola, so go ahead and try this one. Okay, so this is a hyperbola again because of that subtraction. Make sure that regardless of what order the letters come in the problem, that x gives the x part of the center and y gives the y part of the center. So our center is at 3, 2. Then under the y is a 4, so take the square root of that 4, which is 2, and go up and down 2, since y is up and down. Under the x is a 9, so take the square root of 9, which is 3, and go out to the left and right 3 from the center, and make your rectangle. Draw in the diagonals of that rectangle, which give us our asymptotes. And since the y comes first, it's in the top and bottom sections. If the x came first, it would be in the left and the right sections. One common mistake that students make when graphing these is taking those hyperbola branches all the way into the center and trying to connect. They should not cross inside of the rectangle. Okay? On the edge of the rectangle are the vertices, so it should just hit the rectangle and bounce right back off.
All right, so do the hyperbolas just bounce off the center of the,
They bounce off the vertices, which will be right in the middle of those sides of the rectangles.
Okay.
What type of a conic is this? An ellipse. We can tell because it's an addition and because the numbers on the bottom are different. If the numbers on the bottom were the same, that would be a circle. Because a circle is like a special case of an ellipse where it's just as wide as it is tall. An ellipse stretches out that circle, so one way will be longer than the other way. With different numbers in the problem gives us an ellipse. We need to find our center, which is going to be at the opposites of the numbers that are being added and subtracted. Under the x, I put a 1 so that everything would be as a fraction. So we take the square root of that, which is still 1. And since it's with the x, x is sideways. So we go sideways from our center 1 in each direction. Under the y is a 9. So we take the square root of that, which is 3. And from our center, go up and down 3. Oops. 3. Okay. And then connect around to get your ellipse. You do not need to give your foci. Okay. So plot your center. Then take the square roots of the numbers that are the denominators, and that tells you how far to go out and how far to go up and down. The next one's also an ellipse, so give this one a try. Okay, so this is an ellipse again. First thing we do is plot our center which is at 2, 0. There's nothing added or subtracted from the y, so that means that the y didn't move for the center. So the x goes over 2, but the y had no change. Under the x is a 25. Take the square root of that, which is 5, and that tells us how far to go in the x directions. Under the y is a 4. Take the square root of that, which is 2, and that tells us how far to go in the y directions. And connect around. Questions? So the only conic we have not yet talked about is a parabola. Parabola, how can we tell?
Because there's only
minus
one square.
something.
Only one is squared. Okay, so only one is squared, and there's variables on both sides, but if they weren't in standard form, that could be true either way. But only one is squared, which gives us that this is a parabola. Now with parabola, we need to decide whether it's horizontal or vertical as well. So according to the chart, which one does this match up with? Horizontal. When y is squared, that matches up with what the chart says is a horizontal parabola. So a parabola does not have a center. It has a vertex, but the vertex is located at HK. Once again, make sure that the x is giving you the x part of the point and the y is giving you the y part of the point. I'm going to, for some reason, these are really tall, so I'm going to cut them down in half. I don't know why they're so tall. So I plot my vertex there at 8, 6. Then for a parabola, the graph is not complete without the focus and the directrix, so we need our focus and directrix as well. In the chart, it says that this number in front of the parentheses is supposed to be p, which means that in this problem, p would be equal to -1. P is the distance from the vertex to the focus. And since this is a horizontal parabola, I'm going to go sideways, -1 to make my focus. -1. Negative is a left or down direction. And since it's horizontal, it must be left.
Draw the directrix.
We do need to draw the directrix as well. I got -1 because that coefficient in the chart says should be 4p. And so in this chart, if it's 4p is -4, then p must have been -1. We need the directrix as well, which is 1 in the opposite direction of the focus.
And are we going to get marked up to y?
No, you don't need to make XY charts, and so the width is going to be very relative. Remember, the bigger value it is, the wider it should be, but I'm not going to be picky about that.
Oh, so we can just sketch it in.
Just sketch it in. Okay, you do need your focus and your directrix. I will be picky about those being there and it facing the right way and all of that, but the width of the actual curve I will not be picky about. Last one, go ahead and try this parabola. And while you're doing that, I'm going to give you some perspective on conics. It seems like we're just graphing, random silly shapes. But conics are actually extremely useful in terms of a lot of practical everyday objects. For example, contact lenses and the lenses in eyeglasses are defined by conic sections. And the different amount of curvature would define a different prescription then. The mirrors that you sometimes see at like drive-thrus, or sometimes they have them in department stores where they're a rounded mirror, okay, so that you can see more for security purposes. Those are the planets go orbit around the sun in an elliptical pattern, so conics become pretty important in the study of astronomy. So they actually have a lot of applications in different areas. All right, so this one is a parabola again because only one of the variables is squared. The variable that is squared is x, which means that this one is a vertical parabola. We're going to plot our vertex, which will be at the opposite of the numbers in the parentheses, 1, -3. We need our p-value, which we find because our coefficient is supposed to be equal to 4p. So that means p must be 2. Since this is vertical and I got a positive value for p, I'm going to go up 2 to place my focus and opposite down 2 to place my directrix. The bigger the p-value, the wider the graph. So this one should be drawn more wide than the last one, but I'm not going to be picky about that width.
Do we have to label like the focus with an F or with its coordinates?
You do not have to label the focus with an F or with its coordinates. I just do that for myself more so I remember what I'm supposed to go through. You want to go around the focus.
And you need to label with the vertex or the directrix too?
No, you don't need to label any of them. So on your homework, the directions do tell you to identify the key features of the graphs, being the vertices and the foci and whatnot. You do not need to label them. You don't need to find your foci in the hyperbola or the ellipse. Do them just as we did in our notes, just plotting the points that are necessary for the graph itself.